Hello everyone, welcome to School Math Simplified. As you know, we have started Chapter 5 number play, and today we are on the first figure it out of this chapter. So let's start without any delay. The question number 1 is the sum of four consecutive numbers is 34. What are these numbers? मैंने बताया था आपको consecutive numbers क्या होते हैं जो continuous रहे, right? Any four consecutive numbers, and we have to take their sum, okay? And their sum is already given, that is 34. So many clues are given in the question. We just need to find out those numbers. Let's do it. So I'm taking those numbers. This is the question number 1, okay? Let x plus 1, x plus 2, and x plus 4. These are four consecutive numbers. मैंने यहाँ पे 1 2 3 4 क्यों नहीं लिया? क्योंकि जब हम 1 प्लस 2 प्लस 3 प्लस 4 करेंगे तो आंसर 34 नहीं आता है, राइट? तो यहाँ पे जर्नल फॉर्म लेनी पड़ेगी. So these are the journal terms, okay? So according to question, x plus 1 plus x plus 2 plus x plus 3. Sorry, this is 3, okay? Not 4, 3, okay? The sum is equals to 34. Now, adding all the x term 1, 2, 3, 4. 4x are here, so it will be 4x plus 2 plus 1, 3, 3 plus 3, 6. 4x plus 3 is equals to 34. 4x is equals to 34 minus 6. So when we subtract it, we get 28. So x will be 28 by 4. By cutting, you will get 7. So x values 7. If x is 7, then other terms will be, if this is 7, 7 plus 1, this is 8, 7 plus 2, this is 9, and 7 plus 3, this is 10. So these are the consecutive terms. Okay, the sum is 34. You can check also if you want to verify the answer. See, 7 plus 8 plus 9 plus 10. 7 plus 8, 15. 15 plus 9, 24. 24 plus 10, 34. I hope this is clear to you. This is the answer of first question. Moving back to the second question. Now, see, this is the second question. Suppose P is the greatest of 5 consecutive numbers. Describe the other 4 numbers in terms of P. This is easy one. So how to do it? See, this is answer of second. They are saying P is the greatest number. This is the greatest among 5 consecutive numbers. You are given 5 consecutives, okay? And P is the greatest one. This is easy. One step previous, one step behind, it will be P minus 1. One step behind to P minus 1, it will be P minus 2. And then one step back, it will be P minus 3. And again, one step back, it will be P minus 4. So P minus 4 is the smallest among them, and P is the greatest number. Simple. Fine. So these are the 5 consecutive numbers. Moving to the question number 3. For each statement below, determine whether it is always true, sometimes true, and never true. This question was also in text question, as we have done in the last lecture. So here also some statements will be given, okay, or you need to claim your answer by giving examples and non-examples. They are asking for examples as well as non-examples, okay, and you just justify your claim using the algebra, because we are doing number play and we have leveled up about the numbers, so we'll use some algebraic term. Fine. So question number 1. Statement number 1, that is, the sum of two even numbers is a multiple of 3. The sum of two even numbers is a multiple of 3. So this is sometimes true. ST means sometimes true. How? I'm giving you example. Example is like 2 plus 4. Yes, this is 6, which is a multiple of 3. 8 plus 10, 18, which is also multiple of 3. 14 plus 16, 30, which is also multiple of 3. But if I add, so these are the examples. Hmm? These are the examples. So known examples. What are known examples? Known examples like 2 plus 6, 8. 8 is not multiple of 3. 4 plus 10, 14. 14 is not multiple of 3. So this statement is sometimes true. And these are the example and these are the known examples. I hope you are clear about the examples and known examples. So this is the answer of this part. Second statement is, if a number is not divisible by 18, okay, then it is also not divisible by 9. So if a number is not divisible by 18, it is also not divisible by 9. So this statement is sometimes true also. This also is sometimes true. So what are the examples? See, example is 40. 40 is not divisible by 18, right? And 40 is not divisible by 9 as well. Clear? What is this sign? 40 divided by 9. We used to say like this, if we cut this sign, it will be cancelled. Okay, so that's why I'm taking this sign. Otherwise, you can write also 40 is not divisible. I'm writing divisible as div by 18. So, and not divisible by 9. So this is example. So what is non-example? Non-example of this part is non-example NE 27. Take 27. 27 is not divisible by 18, but it is divisible by 9. Right? So this is sometimes true. Okay? If a number is not divisible by 18, it is also not divisible by 9. This is not always true. Okay? So, third part. Third part is, if two numbers are not divisible by 6, then their sum is not divisible by 6. So this is never true. ये तो हमने in-text part में भी किया था. This is never true. If two numbers, say 8 and 10, right? I'm taking 8 and 10. They are not multiple of 6. But 18 is, right? 18 is divisible by 6. You can take any other example as well, like 10 and any counter example like this, 10 and 13. 23 is not divisible by 6. And their sum, yeah, 10 and 13 both are not divisible by 6 and their sum is also not divisible by 6. So this is never true. Part 4. The sum of a multiple of 6 and a multiple of 9 is a multiple of 3. The sum of multiple of 6 and multiple of 9. So this is a big yes because it is done yesterday also. Multiple of 6 and multiple of 9. I'm taking it in algebraic form. Multiple of 6 say 6x and multiple of 9 say 9y. And their sum 6x plus 9y. So which thing is common among them? 3 is common among them. 2x plus 3y. So obviously this term is a multiple of 3. Right? This is true. Last part, the sum of a multiple of 6 and a multiple of 3 is a multiple of 9. Okay. So this is sometimes true, ST, sometimes true, how, see, for this. This is sometimes true. Okay, I'm writing here. And how, the examples are like multiples of 6 are 6, 12, 18, 24, 30, right? And multiple of 3 are 3, 6, 9, 12, 15, and 18. So pick anything, pick any two numbers and add them, right? So adding 6 plus 12, answer is 18, which is a multiple of 9, right? If I take 12 plus 18, hmm, it will be 30, which is not a multiple of 9. Clearly? So sometimes true. Yes, it is coming with some pairs but not coming with the others. Okay, some pairs are satisfying this, others are not satisfying this. So this is sometimes true. Clear? Now moving to the next question. Question number 4. Find a few numbers that leave a remainder of 2 by dividing when dividing by 3 and a remainder of 2 when dividing by 4. Write an algebraic expression to describe all such numbers. Okay, so let's do this question. Question number 4. So when the remainder is 2 and when divisible by 8, so matlab dividend is given. Dividend. Remainder 2 है and dividend is 3. This is given to you. As you know, you have a formula. The number equals to quotient into dividend plus remainder. This is the formula. Now we don't know the quotient, so we are taking it x. Dividend is 3 and remainder is 2. The number is of the form 3x plus 2. कल किया था ना? When the remainder is 3 and which when divided by 3, the remainder gives, it leaves remainder 2. The term will look like this. Okay, this is algebraic expression. And if we want to know what numbers are these, we can put the values of x as 1, 2, 3, and so on. You will get the value like 3 into 1 plus 2, which is 5. 3 into 2 plus 2, which is 8. 3 into 3 plus 2, which is 11. So this is a series of these kind of number which when divided by 3 leaves the remainder 2. Clear? These kind of numbers are this. And secondly, they are asking about like 3x plus 2 is the algebraic expression, right? And they have also asked for the numbers which gives the remainder 2 when divided by 4. And similarly, those numbers will be of kind 4x plus 2. They will be of this kind 4x plus 2. Same way, okay? We use the same way and we get this formula. And those numbers will be, if by putting the value of x, you will get the terms like 6, 10, and 14 by putting the value of x in this term also. You will get this series. Okay. Now, I think that's all. This is what they have asked. Write the algebraic expression, and we have already found the algebraic expression. The main trick is this. This is the formula to find out. If you are given remainder, you are given dividend, just put the values here and take the quotient as any variable. You can take it as k, you can take it any alphabet a, b, c, d, anything, right? I have taken x. I'm comfortable with that, but you are comfortable with another, you can take that. Okay, so these are the two expressions, 3x plus 2 and 4x plus 2. These are the two algebraic expressions. Moving to the next question. Question number 5. I hold some pebbles, not too many. When I group them in threes, one stays with me. Okay. See, this is matka, you can say. I hold, so this is like a puzzle. So this is like a puzzle. I hold some pebbles, not too many. When I group them in threes, one stays with me. Try pairing them up, it simply won't do. A stubborn odd pebble remain in my view. Okay. Group them by five, yet one still around. By grouping them by seven, perfection is found. More than 100 would be far too bold. Can you tell me the number of pebbles I hold? Good. See, they are saying when it make the group of three, one left. When it makes the group of five, again one left. And when it takes the group of seven, it will be a perfection is found. No, nothing will be left, right? So 3, 5, and 7 are prime numbers. 3, 5, and 7 are prime numbers, and we need to find out the pebbles around, right? So first we will find the LCM of 3, 5, and 7. LCM of 3, 5, and 7. LCM of three prime numbers is the multiplication of them. Okay, no need to do this method, prime factorization method. No need to do that. Just multiply all the terms. You will get 105. And whenever you get, like, there will be 105 pebbles, but one is still around, right? They are asking now when it is imperfect method, imperfect way, it will be 105 plus 1. So 106 pebbles are in the jar. Yeah. So moving to the sixth question, that is, Tathagat has written several numbers that leaves a remainder of 2 when divided by 6. He claims if you add any three such numbers, the sum will always give the multiple of 6. Is the claim true? So, firstly, we can easily make the expression that is 6k plus 2. When divided by 6, it leaves the remainder 2. By putting the values of k here, 1, 2, 3, and so on, you will get the series as well. And the series will be like, I'll do it on the next page. So the term is of the form 6k plus 1. Put k, 1, 2, 3, and so on. By putting the term 1, first term will be 8. By putting the term 2, we will get 10. By putting 3, we will get, sorry, this is 14, right? This is 14. This is 20. By putting 4, this is 26. Okay, so this will be 26. So the series will be 8, 14, 20, and 26. Now what they are asking? They are asking in the question, he claimed that if we add any three such numbers, the sum will always be the multiple of 6. Okay. So if add these three numbers, let's see, 8 plus 14 plus 20, add them. The answer is 42. Is it multiple of 6? Yes, this is for multiple of 6. Let's add the other pair, 14 plus 20 plus 26. Add them. It is 60. 60 is the multiple of 6. Yes, this is also, so it's, the claim is true, right? Claim is true. Moving to next question. Question number 7. When divided by 7, the number 661 leaves a remainder 3. Fine. And 4771 leaves a remainder 5 when they are divided by 7. So without calculating, can you say what remainders of the following expression will leave when divided by 7? show the solution both algebraically and visually. Okay, so you have asked for the two statements. So first term is 4779 plus 661, and second term is 4779 minus 661. Nothing to do, right? See. We are given when 661 divisible to 7, it leaves the remainder 3, and when 4779 divisible to 7, it leaves the remainder 5. We are using this thing only, right? So let's add it. Plus 661 when it is divisible to 7. 4771 leaves the remainder 5 and 661 leaves the remainder 3 when divisible to 7. By adding, we get 8 by 7, and when we divide them, we get 1 as a remainder. I hope this is clear to you. जब आप 8 को 7 से divide करेंगे, you will get 1 as a remainder. And when we subtract it, and divide it with 7, the remainders also will be subtracted, and it will be 2 by 7. So the remainder will be 2. Remainder will be 2. Clear? So this is the algebraic method. Now they ask for visual method also. Visual method. Let's do it with visualization. By visualization. So by visual method, nothing to do. As we know, 4779 when divided by 7 leaves a remainder 5, and 661 when divided by 7 leaves a remainder 3, right? So just put these things in the addition. 4779 plus 661 equals to 7k plus 5 plus 7k plus 3. 7k plus 3. Here k's are not same. Just keep this in mind. K's are different. So I'm taking it k1 and this is k2. Okay. If this is k1, this is k2. Now all the k's, 7 common. K1 plus k2. This is the term plus 8. Okay. When the term is divided by 7, when this term is divided by 7, obviously this is divisible. But when we divide these terms, 8 and 7, we get the remainder 1, right? By visually, we get the remainder 1. And same when we subtract the terms, 661, we get 7k1 plus 5 minus 7k2 minus 3. Yeah. So 7 times of k1 minus k2 plus 5 minus 3 is 2. Again, which when divisible to 7 divided by 7, we get remainder 2. Why remainder 2? Because the first term is wholly divisible to 7, right? And we are left with this 2. Yeah? So this is method to solve this, and we are now at the last question. Find that number leaves a remainder 2 when divided by 3, leaves a remainder 3 when divided by 4, and leaves a remainder 4 when divided by 5. Can you find such number? And this should be the smallest one, right? What is the smallest such number? So the easiest way is to firstly find out the LCM. LCM of what? LCM of 3, 4, and 5. Which when divided by 3, divided by 4, and divided by 5. We'll find out the LCM. LCM of 3, 4, and 5. 3, 4, and 5, the LCM will be, you can find out by prime factorization. 3, 2, 5, 2, 3, 1, 5, 3, 1, 1, 5, and then 5. By multiplying, we get 60. LCM of these is 60, right? And this is the formula to find that smallest number which leaves the remainders by dividing these numbers differently will be LCM of this number minus 1. 60 minus 1, which is 59. So 59 is the smallest number that leaves the remainder 2 when divided by 3. It leaves the remainder 3 when divided by 4, and it leaves the remainder 4 when divided by 5. This is the smallest such number, and this is a trick. Okay, so we are done with the first figure it out. Make a copy of it, make your own notes. If you find any confusion, you can contact me personally, or you can comment in comment section. Thank you so much.